So yeah, this is going to be session 2, going from Algebra 2 to pre-calc. All right, so we got some good stuff today. We're not going to be able to cover everything that there is in a document, so that is going to be homework. And by the way, these sessions, they're going to be Monday. No, this one's going to be Tuesday and Thursday, 3 to 4 p.m. Eastern Standard Time. All right, and we're gonna have these next week as well. So next week is when we're going to start seeing a little bit more of like some pre-calc concepts. All right. So right now we're still in full on review mode to make sure you have that really solid foundation before we tackle into some of your stuff. So yeah. So everyone get your notebooks, get your pencils, calculator, all that good stuff. See some people shifting. Awesome. All right, just get everything you need. We're ready to get started.
All right, so open up the doc and give me an R in the chat once you're ready with the doc open in front of you, ready to follow along, take notes. Here it is one more time for anyone who may have came a little later. So documents in the chat, just dropped it there right now. Perfect, let's get started. Okay, let's see. One sec. All right, Regina Torres, can you read the first question for us?
Which quadratic function in vertex form has a graph with the vertex -2, -7, and passes through the point 3, -32?
All right, awesome. So first thing that you want to know is vertex form, right? So vertex form of a quadratic, right, is going to be y equals, everyone write this down, a times x minus h squared plus k, okay? Where the vertex is represented by the point h comma k, okay? And one thing you want to realize is x minus h, right, is going to be in parentheses, right? So the sign is always going to be opposite, right? So if h is positive, then it's going to be x minus h. If h is negative, it's going to be x plus h in the equation, okay? And then k is going to be the same sign, okay? Awesome. And then a gives us like how wide or how narrow it is, right, as well as the direction. So first thing, right, let's go ahead, and we know that they give us the vertex, which is, again, we call h comma k, right? So Regina, if we're going to plug that into this formula, y equals a times, is it going to be x plus 2 or x minus 2?
Would it be +2?
Good, right? Because it's always going to be the opposite, right? So h is always, if you want to even write that down, right? Let me move this over. H is going to be opposite, right? The opposite sign. K is going to be the same sign, right? Awesome, right? So it's going to be x plus 2 squared. And then is it going to be -7 or +7?
+7.
Almost. So remember, the k part is always the same sign. So what would it be?
Oh, sorry, -7.
Good, right? -7, perfect, right? So just knowing that, right? We don't know a yet, right? But we know that it has to be x plus 2 squared minus 7, right? So we're going to automatically eliminate anything with x minus 2, right? So we'll eliminate d, and we'll eliminate anything with plus 7, right? So we know a can't be right, e can't be right, right? Now the question is this going to be a positive parabola, where it's +1, or is it going to be negative parabola, where it's -1, right? And just remember, right, a positive parabola, if a is positive, right, here's write this down. For a, right, if a is positive, it's going up. If a is negative, it's going down, right? So let's see, who else can I call on? John W. The vertex, what is the vertex when you're talking about a parabola?
It's like the starting point, I guess, or like.
Good. It's the starting point, right? So it's like the maximum, okay, or minimum, right, of the parabola. It's the max or minimum value, right? So it's either going to be the highest. If it's a maximum, it's going to be pointing down, right? This is a negative parabola, right? Or if it's a minimum, it's going to be pointing up, right? So what can we use in this equation to figure out it? This question to figure out if it's a positive or negative parabola. What else do they give us in the question? So we already used the vertex. John, I'm talking to you. So we use the vertex, which is -2, -7. What else do they give us in the question?
They give us the point 3, -32.
Awesome. They gave us the 0.3, -2, right? So we were to draw like a really rough graph of this, right? We'll graph the vertex at, we'll say -2, -7. We'll say this is -2. So this is -7, right? Oops. -7. So that's right there, right? 3, -32. Where's that going to be? Is that going to be higher or lower?
That's going to be lower.
Lower, right? So 3, we'll say this is 3. -32, we'll say it's all the way down here, right? So we'll say that's all the way down there. So if this is the vertex, is it going to be the maximum or minimum?
That's going to be the minimum.
Almost. So think about it. This is the vertex, right? So that means it's either going to be the highest or the lowest point. And since the point is lower, are we going to draw the parabola going down or going up? No, you're good. You're good.
So it's the maximum.
Awesome, right? Because we're going to connect that. We're going to draw this parabola going downwards, right?
Yeah.
Awesome, right? So we're going to draw that down, and we'll draw this line down, right? So we know it's going to be a negative parabola. It has to be negative, right? So what would the answer have to be, John?
The answer would have to be C.
Awesome, because it's a negative parabola. Good stuff. And if you wanted to find the exact value of A out, you would plug in what? -3 and 32 for X and Y, but we didn't have to do that, right? And then you would solve for A. But we can just graph it to see that, okay, it's a negative parabola, so A has to be negative, right? And one more time. A is negative, it's pointing down. A is positive, it's pointing up. And that is vertex form. Give me a V in the chat if you feel pretty good about vertex form. If this question makes sense, let's get a V for vertex. So on like the SAT and ACT, they're not going to give you vertex form. You got to memorize vertex form. So just make sure to remember it, okay? Remember vertex form. Remember that X is always opposite. H is always the same, okay? All right. The next question. Let's get, how about Amy Lopez?
A rectangular prism has a volume of 6x cubed minus 13x squared minus 14x minus 3 and a height of 3x plus 1. Which expression represents the area of the base of the prism?
Okay, perfect. So Amy, what is a rectangular prism? What are you picturing right now when you see rectangular prism?
Like a rectangular shape, and then I don't really remember what prism is.
So it's like a rectangle. A prism is basically, picture like a cube, except it's the size, it's like a rectangle, right? So it's gonna have a base, and it's gonna have like the base, which is like the area of a square, which is just length and width, and it's also gonna have what? A height, right? Do you see that, Amy?
Yeah.
Awesome. So this is a rectangular prism, right? We have a length, a width, and a height. So how does the volume? So what's the volume of rectangular prism?
The 6x cubed, 13x.
Really good. Well, what's the formula for volume though?
Formula for volume is length, width, and height.
Perfect, right? Length times width times height. And the question is saying what represents the area of the base. So the base is just a rectangle, right?
Yeah.
What's the area of a rectangle? if they're using the same variables, LWH.
The area of the rectangle?
Using two of these variables.
Um,
Area would be what? Length times.
Length times, I do not remember.
That's okay. So anytime you want to find the area of like a area of a square would be side square. The area of a rectangle is going to be like length times width. Okay.
Okay.
So the area of the rectangle is LW, and the volume is LWH, right? We can plug into this formula, right? So to solve for the area, right? Because this right here is just LW is going to be the area. You see that? That's going to be the area of the rectangular prism. I mean, the area of the rectangle. Do you see that, Amy?
Yeah.
LW is the area, and they give us volume and height. So we just got to plug in and then solve for so what do they give us for volume? What are we going to plug in for volume?
For volume, we're going to plug in 6x cubed minus 13x squared minus 14x minus 3.
Cool. 6x cubed minus 13x squared minus 14x minus 3. And that whole thing, again, we're using the formula V equals LWH, right? So that's the volume, right? Equals, we don't know the length and width, right? But what do we know?
The height.
L times W times, and what's the height?
3x plus 1.
Awesome, right? 3x plus 1, right? And what's the question asking us to solve for?
Which expression represents the area of the base of the prism. So
perfect. And one more time, what is area? What is the area represented by?
The length times the width.
Awesome, right? We know the area is just going to be length times width, right? So all we got to do here is divide both sides by what to solve for LW?
Divide both sides by the 3x plus 1.
Perfect, right? So divide by 3x plus 1, divide by 3x plus 1. So that was all just a concept, right? Now this is where it gets a little challenging, right? So we divided both sides by 3x plus 1. Is that an answer choice?
No.
No, right? So now what we have to do is exponential long division, okay? So if you guys want to write that, exponential long division. Amy, I really appreciate you. I'll give you a little break. You killed it. Exponential long division. So what you got to do is set it up like you're doing normal division, right? So you're going to have 6x cubed minus 13x squared minus 14x minus 3 divided by 3x minus 1 means you're going to put the division bar, and we're going to put 3x plus 1 on the outside, right? And I want everyone to participate in the chat, okay? So everyone participate. So the first question we ask yourself, we always do it one term at a time, right? We say, how many times does 3x go into 3x cubed? Or 3x times what is, my bad, 3x go into 6x cubed. So 3x times what is 6x cubed? And instead, if it's something squared, just put SQ, something SQ, right? So what would it be? 3x goes into 6x cubed how many times? And here's a tip. Let's look. You can use the answer choices because the answer is going to be up here, right? So how many times does 3x go into 6x cubed? Give me 1 in the chat if you feel like you remember how to do exponential long division. Give me 1, and you can help us walk through this. Anyone remember how to do long division? All right. Oh, Sean. All right. But Sean, you said you can't unmute. Can you unmute now? Isabella, you also said you can't unmute. Can either of you unmute? I guess not. Okay.
For a minute, I was like, what is this newfound knowledge of exponential long division? So I think you mean polynomial long division.
My gosh. Yo, thank you. Yeah.
You probably said that like 4 times. Yeah. Polynomial long division.
Polynomial. Right. I'm just looking at exponents. There you go. Polynomial.
Yeah, these are polynomials, right? You got like
perfect.
The x cubed, x squared. When you have all those terms, those are polynomials, right? So with polynomial long division, yeah, you're good. With polynomial long division, why don't we set another division next to it and just put like 83 divided by 2. Just have that in the same form, 83 divided by 2 in the same form. Yeah. Nice. All right, perfect. So Josh, how many times does 2 go into 8? Josh W.
You mean John?
Oh, shoot. Yeah, John, I'm sorry. All right, John. Yeah, how many times does 2 go into 8?
4 times.
Right, so that goes into it 4 times. So to get the 2 into an 8, you need to multiply by 4, right?
Yeah.
Cool. So now let's take that, let's apply it to the polynomial long division. So we are getting that term. We want to make it look like whatever you have under that little division sign. I don't know what that little thing is called. So what do we need to do to 3x to get it into 6x cubed? First off, what do we need to do to the 3?
Would you have to double it?
Yeah, so multiply by 2, right? What about the x? We go from x to x cubed. What do we multiply by?
X squared.
Exactly. So we need to multiply that first term by 2x squared to get it into 6x cubed. But what you do to one part, you must do to the other. So you also need to multiply the 1 by 2x squared. So let's write all that below. So underneath we have the 6x cubed. We already got there, right? And then we also need to add 1 times 2x squared, right? So we're just going to add what? 2x squared. And now this is starting to look a little bit more familiar. You have 2x squared down, yes, 2x squared down there. And now we want to get rid of the 6x cubed. So we're going to make that whole bottom thing negative. All right, if we make it negative, then the 6x cubes canceled. And now we have, what is 13x squared minus 2x squared?
Negative 15x squared.
Negative 15x squared. And what do we need to do to 3x to get to negative 15x?
Multiply by 5x.
Yes, but keep in mind that it is negative 15x.
Negative 5x.
And perfect. Awesome. So you got to multiply it by negative 5x. Perfect. And then you just keep on going like that, bring down the negative 14, and that is polynomial long division. You just keep on going until you get to the very end. All right. So I think we can just chug this through now.
Perfect, right? So we say 3x goes into negative 15x, negative 5x times, then we multiply negative 5x times 3x plus 1 is going to be negative 15x squared, right? Minus 5x. Let's not forget to bring down that negative minus 14x, right? After you multiply, you put it in parentheses and subtract, right? And you put in parentheses, you don't forget to apply the negative to both, right? So minus negative 15x squared cancels out. That becomes plus 15x squared, right? And that first term's gonna always cancel out until you get to that remainder, right? And then we have negative 14x minus a negative 5x means plus 5x, right? Would be equal to negative 9x because we're adding 5x, right? And then let's finally bring down that negative 3. And now we ask the same question. How many times does 3x go into negative 9x, right? 3x goes into negative 9x. How many times, guys? Or basically 3x times what is negative 9? Drop it in the chat. 3x times what is negative 9? 3x times what is negative 9x? That's what I meant, right? 3x times what is negative 9x? Awesome, right? 3x times negative 3, so put minus 3 on top. And then we do the same thing, right? Now we're going to say, what's negative 3 times the whole thing, right? 3x plus 1. So negative 3 times 3x is going to be negative 9x. Negative 3 times 1 is going to be just minus 3, right? And then finally, put in parentheses after you multiply, put in parentheses and subtract. Minus negative 9x cancels out. When you distribute that negative to the negative 3, becomes positive. Negative 3 plus 3 also cancels out, right? So we have a final answer right here. 2x squared minus 5x minus 3. All right, so answer is going to be D. All right. Sorry, yeah, not exponential long division. I think I just made something up, right? Polynomial long division. Give me a P in the chat if you're going to make sure that, practice polynomial long division. This shows up on the SAT as well. So it's just really good to know how to do polynomial long division, okay? All right, good stuff. And then let's go ahead. Number 37 is an awesome question. Dylan, you want to call on someone and walk through this one?
Yeah, why don't I get Regina Torres? You want to read for me?
Which equation has -2 and 5 as solutions?
Awesome. So how can we get solutions from an equation in this form? Regina. So a solution is an x-intercept, right?
Yeah.
Yeah, so solution is an x-intercept. It's a root. It's also called a zero. We're missing one more word. What is it also known as? Anyone in the chat? What's another way to say solution? The key that's going to help us the most here is also known as a factor. All right. So we can throw in factor there as well. So that's going to get you your solutions, right? So if we can somehow factor these, then you can get into your solutions. So factors, that's going to be your if you put something into factored form, that's going to be your x minus m, x minus n, that good stuff. Factored form, right? Perfect. So factored form is going to be x minus m and x minus n, where the m and n are your solutions. All right. So since we have what is our m, what is our n? What are they going to be equal to? What does the question want them to be equal to? Anyone in the chat? If m and n are solutions, what should they be equal to?
All right, hey, let me break down an example real quick, right? So let's work like with a random example. Let's say y equals x plus 2, right, times x minus 3. These are called factors, right? And guys, what do you set factors equal to get the solutions? We set factors equal to 0, okay? So if you set each factor equal to 0, we're going to get x plus 2 equals 0, and then x minus 3 equal to 0, right? So guys, what would the solution or the x-intercept be for this first one? X plus 2 equals 0. The solution is going to be what? Or the x-intercept is going to be -2, okay? And for this one, the solution is going to be let me see a bunch of answers in the chat. If you solve for x, you're going to get what? For this is a random example, by the way, right? Put it in the chat. If you solve for x in that second example, you're going to get what? Right? You add 3 to both sides, add 3, right? X equals 3. So the main concept you want to understand, right, is that the factors and the solutions are going to be opposite sign, right? So if the solution is -2, the factor is going to be x plus 2. If the solution is 3, the factor is going to be x minus 3, right? Give me an F in the chat if you understand like how factors relate to solutions. Let me see. Wait on a sec, right? So again, if the factor is x plus 2, the solution is going to be -2, right? So it's going to be opposite sign, okay? And remember, factored form gives you your solutions, which are also known as solutions are the same exact thing as x-intercepts, roots, and zeros, okay? And again, we're calling them zeros because we set y equal to 0. Cool? All right. So guys, drop it in the chat. If -2 is a solution, then what's the factor going to be? What would the factor be? If -2 is a solution, the factor is going to be, remember, a factor can't be a number by itself. It has to have an x, right? X plus or minus something. So if the solution is -2, the factor is going to be here. Look at these examples, right? If the solution is -2, so this is the one we just did, right? The factor is going to be x plus 2. So it shouldn't be equal, right? It's a factor is going to be x plus or minus a number, right? One more time, give me an F in the chat if you understand that x plus 2 is a factor, x minus 3 is a factor. Give me an F. Those are factors, right? Give me an S in the chat if you understand that the solution to x plus 2 is going to be -2, and the solution to x plus 3 is going to be +3. Give me an S for solution, right? Okay, so remember, factors have x plus or minus, okay? Cool? All right, so one more time. If -2 is a solution, what's the factor going to be? Awesome, Amy. And let me see a bunch of people, even if you already see the answer, drop it in the chat. If -2 is a factor, if -2 is a solution, the factor is going to be x plus 2. Okay. And then if 5 is a solution, the factor is going to be what in the chat? Let me see a few more answers. There we go, right? X minus 5, okay? Good stuff, right? Now this is in factored form, right? Let's see. Miles Kavanaugh, can you unmute yourself? Miles, you there?
Yeah.
Hey, what's good, Miles? Okay, so right now it's in factored form, right?
Yes.
All these answers are in what form? Do you remember what it's called?
Forgot what it's called.
That's okay. Standard form, okay?
Okay.
Which is y equals ax squared plus bx plus c. Do you know how to go from factored form to standard form?
Yes. You would like foil them.
Awesome, right? We got a foil. Good. We're gonna foil, right? So when you foil, you do first. Foil means first. What's x times x?
X squared.
Awesome. And then what is x times -5?
Minus 5x.
Good. And then
Plus
I is
2x.
inner, right? 2 times x is plus 2x. And then finally, 2 times -5 is minus 10. Combine like terms. What is -5x plus 2x?
Negative 3x.
Minus 3x minus 10. Awesome. So what's the final answer, guys, in the chat? Appreciate it, Miles. Everybody drop it in the chat. What's the final answer? Cool. It's an easy question if you know this, if you know understand the concept. Okay, so your goal, right, needs to be to master the concept, because again, all these concepts, I promise they're gonna show up again. Okay, on the SAT, ACT, college math. Dylan, do you want to add to that?
Yeah, so I saw someone in the chat that couldn't we plug in -2 and 5 into the equations? So we definitely can do that, right? If you're not sure where to go with a specific question, plugging in values is going to be your best bet, right? But the thing is that takes a really long time. Okay, so because you're gonna have to look at each of the questions and start with interest. Hey, what is 2 squared minus 3 times plus 3 times -2 minus 10? Is that equal to 0? Okay, good. And then what is 5 squared plus 3x minus 10? It's going to take a really long time. All right, so understanding factored form and manipulating it into standard form, that's what they're testing. So if you can do that, then you're gonna have enough time to answer all these types of questions in the test.
Really good. Yeah, we took like 5 minutes to explain the concept, but guys, in the chat, how long would it take just to write this out? If you just understood, okay, -2 means if the solution to x minus 2, how long would this take to write out in the chat? Just start the factors, to FOIL, combine like terms. How long do you think that would take?
I mean, I think that if you know what you're doing, right, and you have sloppy handwriting like me, you can do that in a couple of seconds, right? You can write everything down in like 30 seconds and get your answer.
Yeah, like 30 seconds max, right? So again, just make sure you understand the relationship between solutions and factors, okay? Concepts, understanding concepts is your goal, right? You could plug in, but again, you'd have to plug in -2 and 5 for all the x's, right? Until you get the correct answer, okay? But again, plugging in, it's really good, but your goal right now is understanding concepts, right? So that's what's gonna help you in the long run. You want to skip 38? Dylan, what do you think? Which question do you think we should do next?
Yeah, this is another long division question. Let's do 39.
Yeah. All right, perfect. So let's have Christian Corte.
Yes. Would you like me to?
Hey, how you doing?
Hey, how are you doing?
Good, man. Really good to see you. Can you read the question for me?
Yes, I can. What is the simplified form of? Wait, am I reading the right one? 39?
Yeah, 39.
Okay. What is the simplified form of the expression square root of 156?
Perfect. Thank you. Okay. So anytime you want to simplify a radical, right, you want to ask yourself, right, what perfect squares go into 156, right? So when you think of perfect squares, you want to think of like 4, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, right? So let's go ahead and see, like, for example, is 156, what is it divisible by? What number do you want to check, Christian? Everyone should have their calculator, right? And everyone put in the chat as well. See what perfect square is 156 divisible by? And Eric, right? Eric is a champ, right? He gave us a answer in the chat. So 156 divided by 4 is what, Eric? What's 156 divided by 4? Awesome, right? So the perfect square that goes in 156 would be 4, right? So we can break up 156 into radical 4 times radical 39, okay? Just make sure you understand that, right? You can break up radicals, and when you multiply it, it's going to come back to 156, radical 156, okay? Give me a B in the chat if you see that you can break up radicals like that.
Well, can I put a little in-between step there? Yeah, so you can rewrite 156 as 4 times 39, right? So you can just have all of that under a square root. So square root of 156, sorry. So the square root of 156 is going to be equal to the square root of 4 times 39, right? All under the same radical, right? So you're there, right? Now, when you're multiplying things under a square root, now you can pull that apart. And that's going to be equal to a square root of 4 times the square root of 39. And guys, the square root of 4 is going to be 2, right? So square root of 156 is equal to 2 times the square root of 39. And if you want to double check, you can pull up your calculator and you can type in square root of 156 and 2 times square root of 39, and you will get the exact same value. All right. So just break it apart within the radical, and then you can pull things out. But you can only pull out perfect squares out of a square root and perfect cubes out of a cube root, things like that.
Perfect, right? And again, you could assume that, okay, I could just use my calculator for this question, right? Square root of 156, get a number, plug all these into your calculator, right? But let's assume this is a no calculator question, okay? And you want to be able to solve this if you had no calculator, okay? Great stuff, everyone. Number 40, exponent, right? Exponent rule. So, Dylan, you want to walk us through this one?
Yeah, absolutely. So we have the cube root of 64 times x to the 5th. Okay. So guys, remember, when we have something in the square under a root that's being multiplied, we can pull that apart, right? So the cube root of 64 times x to the 5th is the same thing as the cube root of 64 times the cube root of x to the 5th. So we can go ahead and rewrite that. Awesome. So guys, a cube root is asking, okay, what number times itself 3 times is going to give us this number? What is the cube root of 64, guys? In the chat. Nice. Come on, guys, a little bit more. There you go. Awesome. 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 Yeah. 4 times 4 times 4, that gives you 64, right? 4 cubed is 64. All right, so that part on the left is going to give you 4. Awesome. Now, whenever you have exponents, right, with powers and radicals and all that, you can put it into a fraction, okay? The power is going to be on the top of the fraction, and the root is going to be on the bottom, all right? If you're going to think like, oh my God, how am I going to remember which one goes on top, which one goes on bottom? Think of just a regular fraction, right? So whenever you have something to the power, a power is going to increase the value, right? X squared is going to be greater than X. X cubed is going to be greater than X squared. So if that top number is high, right, that's going to increase the value. What does a root do? A root decreases the value. Okay, so a root is going to be on the bottom. All right, so x to the so how can we write the cube root of x to the fifth? What number is going to be on top, 5 or 3? Which one increases the value? What goes on top, 5 or 3? Which one's going to be increasing the value of x?
And if it helps you remember, just remember power over root. Whatever is the power stays on top. Whatever is the root comes down, right, to the bottom of the fraction. Okay, so power over roots. Okay, so let's look back at this. It's what's going to be on top, guys, in the chat one more time. I only got one answer, so it's going to be power over root. Power over root. Let me get a couple more answers. I know there's more than 3 of you.
Nice.
Awesome, right? So 5 over, and then what's the root?
What is the root? What are we putting on the bottom?
3.
Awesome. There you go. 3. Perfect.
Really, really good job.
So there it is. This is the exact same. This is a simplified form of cube root of 64 times x to the fifth. All right. So you can break up things under a radical, right? You can break them up if they're multiplied. You can break them up. All right. And also fractional exponents. Okay. That it's going to be a base to the power over a root. It's going to be the increase versus over the decrease.
Perfect, right? And another way you can look at this, just using this rule that we just learned, right, is anytime you take the cube root, it's the same thing as raising it to the 1/3 power. Anytime you take the square root, it's the same thing as raising it to the half power, right? So the cube root of 64x to the fifth is the same thing as 64x to the fifth, right? One more time, raised to what power in the chat? The cube root is the same thing as raising it to what power? So the square root is 1 over 2. The cube root would be raising it to what fraction? Really good, Christian, right? Awesome, right? So it's the same thing as raising it to the 1 over 3. And the rule with exponents, right, is anytime you have a power to power, you need to distribute that power to each term, okay? So it's going to be, you're going to distribute, there's a 1. Any number is always raised to the 1 power, right? So you're going to distribute the 1/3 to the 5 and that 1/3 to the 1, right? So it's going to be same thing as 64 to the 1/3 times 5 times 1 over 3 is 5 over 3, right? X to the 5 over 3. And then with your calculator, right? 64 to the 1/3, if you just put it in your calculator, right, it's going to be equal to 4. Basically, what times itself 3 times 64, right? 4 x to the 5/3. Okay. Both of these ways are really important, right? Make sure you understand both.
I think this is just more power rules.
Perfect, right? The main rule, whenever you have a negative exponent, just make sure you bring it down, okay? So this would actually be 1 over 6e to the 9th, right? Times 1 over 3. Oh, my bad.
Yeah, whenever you have a negative
negative
exponent, just put it on the other
3
side of the fraction.
Yeah.
Yeah, just put it on the other side of the fraction. So in the first part, that's in the that 6 to the 6e to the negative 9. That's like 6e to the negative 9 over 1, right? So those are equal to the same thing. So whenever you have a negative exponent, just flip it. Okay. If the negative exponent's on the bottom, flip it to the top. That's it. Just flip it whenever there's a negative exponent. All right, let's keep going.
More exponents. All right, let's do number 43 since we talked about factors, right? This is a really important concept. So anytime you're factoring, right, you want to think of what? 2 numbers, okay? This is in standard form, right? You want to think of 2 numbers that multiply to negative 32, right? Multiply to, and add, right, to 4, right? So guys in the chat, what are two numbers that multiply to negative 32 and add to 4? Awesome. 8 and negative 4, right? 8 times negative 4 is negative 32. 8 minus 4 is 4, right? Awesome. So those are the factors, right? It's going to be, just throw that in with x's, right? It's going to be x plus 8 times x minus 4. So what would the answer be in the chat? Awesome, right? Just flipped it.
All right. So let's see. Want to go over 45?
Yeah, that sounds good. Let's do 45.
All right, cool. So let's get something to read. All right, what about Daniel Fernandez?
Number 45.
Yeah.
According to Descartes' rule of signs, can the following polynomial function have exactly 0 positive real zeros? Choose the answer based on the rule only.
Awesome. Cool. So what is Descartes' rule of signs?
Unfortunately, I do not remember.
You're good. You're good. So pretty much what it has to do is it pretty much gives you like, okay, it's asking what is the maximum amount of like positive real solutions you can have. All right. And you can determine it based off of the signs, right? So Calvin, what are you thinking? Ooh.
So if you have what, an x cubic function, right? How many, for example, how many sign changes are in this function right now? How many sign changes do you see? Just looking at the signs. So this is the rule of signs, right? So if we have 2 sign changes, right? The rule is if you have 2 sign changes or 0 sign changes, then this function, right? So the question is saying, right, according to Descartes' rule of signs, can the following polynomial function have exactly 0 positive real solutions? We got to figure out, does this have 0 solutions? Okay. So the answer is if there are 2 sign changes, right? So here, right, we're going from positive to negative, 1 sign change, 2 sign changes, right? Then the answer is going to be yes. Okay. Does that make sense, guys? So 2 sign changes, or no sign changes if they're all positive, right? Then you'll have 0, right? Real positive zeros.
I have a
Yeah, guys.
question.
Go ahead.
What if there is 1 sign change or 3 sign changes? Then how many real positive zeros would there be?
So if there are 3 sign changes, there can be 3 positive positive real zeros or one real zero, positive real zero. All right, so it's going to be that value minus an even minus 2. Okay, so those are your two possibilities. So since there's two, there can be since there's two in this case, there can be two sign changes or zero sign changes. So what happens if there's only one sign change? Okay, so that means there's going to be there's either one positive sign, one positive zero or one negative zero.
Okay, thank you.
No problem. So yeah, Descartes' rule of signs, it's all dependent, it's all changing on it, it all depends on the changing values of the signs, right? So it goes from positive to negative, that's one change. Then it goes from negative to positive, that's another change. So there's two changes and the possibilities are either 2 or 0. How that works, I have no clue, but it's a rule. So I don't know. So yeah, if there's 3 sign changes, then we can either have 3 or 1. And if there's one sign change, there's either one positive or one negative. And yeah, so there can be 0 positive real solutions. The answer is yes, A. And this is going over the same concept.
So in this one, we have what? 1, 2, 3 sign changes, right? So can we have 0? No, right? If there's 3, it's either going to be 3 or 1, right? So this would be no. Okay. Then what do you think we should cover next?
Oh man, it's kind of wild that binomial theorem is in an Algebra 2 class. I definitely didn't see this in Algebra 2. Man,
honestly, I'd say don't worry too much about binomial theorem, right?
Yeah, no, this is not something you're going to see too often.
Yeah.
Yeah. So there's a bunch of binomial theorem questions here. So what are you thinking?
Let me see. Let me see a couple questions that are gonna like conjugate theorem.
Let's tackle 51.
Okay.
All right, cool. So using the complex conjugate root theorem sounds very spooky. All right. So to say another complex solution to a hypothetical function, given that 2 minus 4 to the I, 4i is a root. Okay. So a conjugate is whenever you have a term, you have a expression with 2 terms where the sign in the middle is flipped. That is all a conjugate is. Okay. So what would the conjugate of 2 minus 4i be? Remember that all you need to do is flip that middle sign. What's the conjugate going to be? What's the conjugate of 2 minus 4i going to be? All you got to do is flip that middle sign. There you go. All right. So the conjugate of 2 minus 4i is going to be 2 plus 4i, right? That is the conjugate. So the complex conjugate root theorem means that if you have one complex solution of a system, then you have the other by just flipping that sign. All right. So the answer choice in this case is going to be C. All right, look at 52. 52 is going to be the exact same thing. What's the conjugate of -5 minus 2i? What's the conjugate of that going to be? Remember, conjugate is just flip that middle sign. Boom. Look at that. Let's get some more in chat. It's going to be -5 plus 2i. All right.
And essentially, you want to think when you're talking about solutions, right? You want to think of the quadratic formula, right? It's x equals negative e plus or minus square root of b squared minus 4ac all over 2a. So it's the plus or minus, right? So that essentially plus or minus is what's going on when you're flipping and finding the 2 roots, right?
Yeah, absolutely. So yeah, this is all. It's just going to be that plus or minus sign. Just switching that out. All right, on to the next one. Okay, find all zeros, real or imaginary, of the following functions. Guys, you want to find the solutions that are all real or imaginary for a function. That's your key. That's the or imaginary. That means that you are looking at the quadratic formula. All right, that's going to be your x is equal to negative b. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. If you don't have that equation already memorized, I highly recommend you do. Super valuable stuff. And then just plug in your terms. The key here is that whenever you have a negative number under the square root, right? Whenever you have a negative number under a square root. So just give me like a square root of -4, for example. All right, if you have the square root, of -4, all you got to do is pull out an I, all right, to get rid of the negative. So it's going to be I times the square root of 4, and then just do the square root of 4. It's just going to be 2I. All right, that's it. That's the imaginary. That's what they mean by complex or imaginary. That's it. It's just the letter I. That's all of it. All right, don't let it intimidate you. That is literally it. If you have a negative under a square root, pull out an I. Okay, that's all there is to it.
Because guys, if you remember, right, I is equal to the square root of -1, right? Which means when you square both sides, right, I squared is going to equal to -1, right? So just remember, pulling out an I is basically pulling out a square root of -1. Okay. All right. You want to practice this one real quick?
Yeah, I'm down. So as we already know, we have our quadratic equation that negative b plus or minus square root of 2a, b squared minus 4ac over 2a. Stumbled over that. So just literally plug in your terms. When you have your equation into standard form, you have ax squared plus bx plus c. That's what they mean by a, b, and c. Okay, and then just get those values and plug them in. Awesome. Let's keep it going. So it's going to get you -4 plus or minus square root of, and then 4 squared, guys, is going to be 16. And then minus 4 times 1 is just 4. And then 4 times 8 is going to give you what? 32. All right, all divided by 2. Awesome. So, guys, square root of 16 minus 32 is going to give you -16 all over 2. Okay, and look at that. We have a negative under the radical, right? Negative in the square root. So what are we doing? What are we doing to that? How are we fixing that? Come on, guys. There's like 15 of you. It's not just Caleb in here. We're going to get a 4i, right? 4i. That's just going to be square root of 16 is going to give you 4. And then the square root of -1, that's going to be I. All right. So it's going to be plus or minus 4i all over 2. Okay. And then from there, you can divide the -4 by 2. That's going to give you -2. And then divide the plus or minus 4i by 2. That's going to give you 2i. And those are your two solutions. That's all there is to it. That's as complex as it gets.
So one more time, guys, right? Square root of 16, right? Remember, I is the square root of -1, right? So the I represents, it basically cancels out the negative and the square root, okay? We take out the I, right? So square root of 16, 4, make sure you include the I. That's it, all right? And
yeah, so this right here, it's a pretty similar concept. It's just what's different about it. The only thing that stands out is going to be that instead of having the typical x squared, right, that's gonna have a x to the 4. All right. So you may think, oh no, what are we gonna do now? All right. Best thing to do here is, the issue is that we have x to the 4 instead of x to the 2, right? This is where we're gonna use a strategy called U substitution. All right. The issue is that we have x to the 4 instead of x to the 2. So why don't we just make x squared? Why don't we just make that equal to u, right? Because x squared is x to the 4. So if we just make x squared equal to u and plug that in, now all of a sudden we don't have x to the 4, we have u squared. All right. So if we write it in terms of u, now we have u squared plus 2u is equal to 1. And look at that. We have our x, we have our squared, we have our regular, and then we have our constant. Okay. And now we can solve just as normal. We can factor this out. Guys, what does this factor out to? What multiplies to 1 and adds to 2? And Kelvin, I think you're gonna have to take it from here.
Perfect. Yeah. So it's gonna be u plus 1 squared, right? Or u plus 1 times u plus 1. And then next step, right, is plug it back in, right? So it's gonna, like we said, it's gonna be u plus 1 squared. Well, u is x squared, right? So we can plug that back in for u, right? Sub it back in. That's how u substitution works, right? It's gonna be x squared plus 1 squared, right? To find the solution, right? It's gonna be what? X equals plus or minus the square root of -1, right? Because if you actually solve it, right, x squared plus 1 equals 0, x squared equals -1. We know that x is going to be the square root of -1, right? Plus or minus x equals plus or minus the square root of -1. Well, guys, what's the square root of -1? It's just going to be I. We just talked about that, right? So it's going to be x equals plus or minus I. Okay. So the plus or minus I has a multiplicity of 2. Okay, just remember that, multiplicity of 2. And that's it, guys. It's 4 o'clock. Thank you so much for sticking with us. We talked about just factoring, the conjugate. We discussed factors versus solutions and how they're related, right? As well as polynomial long division, right? Simplifying radicals, some exponent rules, right? And you guys did such a good job. We also discussed vertex form, right? So I hope you found this helpful. And yeah, we'll see you guys next Tuesday. So Tuesday and Thursday next week, okay? All right, y'all. Have a good one. Bye.